Hi guys, how's it going? So in this video we're going to be looking at the stages of the fixed stages of the graphics pipeline. The first step is our graphics pipeline will need to fetch vertices. So we'll just set up some create info for this. So the vertex binding description describes the data layout, so the stride, the batching, that sort of thing. And then we have attribute descriptions, which describe what it means, basically. At this point, we're hard coding all the info into our shader, so we don't need to pass anything special in here. We don't need to pass anything in here, actually. The next step is our graphics pipeline will take the vertex info and stick it together to make shapes. So we have choice of which sort of shape assembly algorithm we want to use and some other things. So that's called topology, where we can choose between triangles, points, lines, that sort of stuff. We also have the opportunity to reuse vertex information by setting primitive restart to true, but we're just going to leave that as false. Now we're going to set up a viewport. This consists of two kind of structures. The viewport, which physically describes an extent, so an x, y, and a width height. And the next section will be a scissor. So a scissor is a kind of test which is applied on top of a viewport after it has been rendered. We may only want to render the top half, bottom half, or something. We're not going to do that. For this, we're just going to render the whole viewport, so we'll pretty much have the scissor set the same as the viewport. We pass both these structures together to the viewport state, and that fully describes the state of the viewport which is rendered to. Okay, so the next part is we have our rasterizer. Now the rasterizer basically fills in the shapes, and the way it does this is it interpolates in both directions, so kind of bilinear interpolation between the points on the triangle. Now the options we can set here are we can specify whether we want to fill a shape or not. And we also have this depth thing. So what depth clamp is doing is you have the option to automatically clamp values or discard them. In this case, we don't want to do automatic depth clamping. And there's this weird option here called Rasterizer Discard Enable, and what that does is it automatically disables the writing of the rasterizer to the fragment shader. So we get information, but we don't pass it through. Now this, I can't think of a single use for this, maybe for compute shaders. We can also set up cull mode. So we can set our cull mode, and we can also define how our front face is going to be set up. A depth bias is helpful in creating shadow maps. So what a shadow map is we take our light and we treat that kind of like a camera, and take a snapshot of the scene to see what the light can see. Then we compare that with what the camera can see. However, if we're casting a shadow onto a sloped object, it can look a little strange, and one way we can get around that is we can have a depth slope, like a slope-based depth, which we're not going to do at this point, but we do have to configure this. Now we have multi-sampling. We're not going to use multi-sampling at this point, we'll look at that later. So for now we're just going to disable multi-sampling and set it to one sample, just to be safe. Okay, so now we're going to set up our color blending. So after our fragment shader has run, the color blend will run, and this will basically, any creative effects that we have, they don't have to be creative. It will deal with alpha blending. If we want to do our own custom algorithms, it will handle that. At this point, we're going to just use the most basic sort of algorithm, which is 1 times the incoming color plus 0 times the existing color. So this will just automatically overwrite fragments on top of each other. And now we're basically going to do exactly the same thing as the color, but just with the alpha. Cool, so we've set that up, we've got that described. That goes into what's called a color blend state. So we're pretty much going to pass that in as a pointer. This song, I used this in one of my previous games, long time ago. I might do a playthrough of that, I don't know. So, nothing too crazy, we're just copying it over. Just, yeah, passing in the reference. We can optionally set, if we're going to do like an add or a multiply, we can specify custom factors for red, green, blue, and alpha as well. Okay, so now we're going to create our pipeline layout. Now, this is basically the set of hooks or pointers which uniforms get to when we send in, uniform. Sorry, not uniform, what am I thinking? Like layout locations, if that makes sense. We'll get to that at a later point. Now we have another, I believe this is a Vulkan specific thing called push constants. So we might have a look at that later, but a push constant is basically a different method to pass in data to a shader. That out of the way, we then construct our pipeline layout. And we run it, and this is an error. So for the pointer to the place where the pipeline is stored, we need to create a member variable to store that. And that's it, it'll run. In the next video, we'll continue this further.